In this video, I'd like to talk about the math question of the day for Tuesday, July 25th, 2023. And with this problem, we're told that Guillermo is a professional deep water free diver. His altitude, in meters relative to sea level, x seconds after diving is modeled with this function here, g of x. What is the lowest altitude Guillermo will reach? And questions like this, word problems involving quadratic functions, will typically be seen in an Algebra 1 class, though you might also see this in an Algebra 2 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And we want to get a visual of what's actually happening here. We're told that Guillermo is a professional deep water free diver, and we're told about his altitude relative to sea level, and we're told about his time, x seconds after diving, and all of this is modeled by this equation here, which you might notice if you actually distribute and multiply this out, you get x squared over 20 minus 5x. And what you can see is that this is a quadratic equation, a quadratic polynomial, or a second degree polynomial. And these are parabolas. So if we want, we can get a general picture of this function here. It's going to look something like this. And we know it's an upward facing parabola because the coefficient on x squared is a positive number here. So with these parabolas, they have very distinct features. One is that they all have a vertex, which is either the highest or the lowest point. It could be the highest if the parabola is downward facing. Now, what we also know about parabolas is that they are symmetrical. So let's say this was on the xy coordinate plane, and we'll say at a y value of 0, this x-axis, this could be the sea level. So anything under is when he's diving down. And if we were to plot the zeros, if we set the y values equal to 0, we can very quickly figure out the intercept, since this is in its factored form, and we can use the zero product property. You can see that an x value of 0 would make this factor out front equal to 0, and 0 times by negative 100 is 0. So at 0, 0, we have an intercept. And we can see if we plug in positive 100 here, that we get 0 multiplied by 5, which of course is also 0. So this point at 100, 0 is another one of the zeros, one of the roots. And what I mentioned about symmetry is that these parabolas all exhibit symmetry around the roots and the vertex. Namely that the vertex is exactly in the middle of the two zeros. So we can use that information if we want to figure out the vertex. Though let's go to our question now. What is the lowest altitude Guillermo will reach? And for us, that will be our vertex, since the lowest point would be right here. Since it is an upward facing parabola, the lowest point would have to be our vertex. So we need to figure out the vertex, though we also need to determine if we want the x value or the y value, or I should say the function value. Now, going back to our equation here, one thing I do recommend is that when you're given units in a word problem, when you're given these variables, start by defining what they are. We need to know what x and g of x actually are in terms of this function. And we're told that in this second sentence here, that his altitude in meters relative to sea level, x seconds after diving, is modeled by this equation. So x seconds after diving, x just represents time, and the unit there is seconds. But g of x looks to model the altitude. So we can say this is the altitude of Guillermo, and this is measured in meters relative to the sea level. So above the sea level is positive, and below sea level, he would be at a negative altitude. Now, to figure out the lowest altitude, we know we're looking for the vertex, and specifically, we want to know the function value there. If the question asks what was the time it took to reach the lowest possible altitude, then we would be looking for the x value at the vertex. But we need to know the actual altitude, meaning we need the y value or the function value there. And here we'll go back to using our knowledge of the zeros. We found these by setting g of x, or y, equal to 0, and then looking at our equation and using the zero product property. We found that an x value of 100 would give one 0, and an x value of 0 would give the other 0. Now, our vertex will be exactly in the middle of those. So what we can do is take our x values, add them together, and then divide by 2 to find their average. And this is just 100 over 2, which is 50. So the x value of the vertex is at 50, and the y value, what we're looking for, we would just plug 50 into our function there. So let's actually compute g of 50. This will give the lowest altitude that he will reach. And if we plug that in, we get 50 over 20 multiplied by 50 minus 100. And this simplifies to 5 over 2 multiplied by negative 50. So if we simplify this, we get negative 250 over 2, which, if we divide this by 2, would be minus 125. And remember, the units are meters relative to sea level. And since he's below sea level, it makes sense that we got a negative number. And this right here will be our final answer.